In an earlier video, I showed how the J8CM stack worked by using the push and pop commands to move data from the accumulator with the push command onto the stack and then pop the information from the stack into the accumulator. Here we're going to see how the stack is used by subroutines to return to the proper instruction once the subroutine is completed. I have over on the right the assembly language program that I'm using for this demonstration, and I'll just go through it quickly. We have at memory location 10, I have the origin statement. So memory location 10 is going to have 5, and then 11 has 10, and 12 has 20. And I've got labels for those three locations, A, B, and C. I have a bug with the assembly language compiler that when I get too many labels in, it gets kind of quirky. And rather than figure out which label's going to work, I just went ahead and put comments next to the next few labels, or the next few memory locations. So what I have in location 13, 14, and 15 are just 1, 2, and 3, and I'm just going to use those numbers. I'm going to load them into the X and Y registers when the subroutine is called. So when I call 1, I'm going to load 1 into the Y register, and when I call 2 and 3, I'll load that into the X register, and that's just kind of keep track of where I'm at as I move through the program. I'll point that out as we move through it, and it should make sense. The 0 is just for clearing out those registers when I exit the the subroutine. Location 20 has the label F, and this is going to be our buffer for the output stream. This program will output 3 bytes of data to the output stream, and location 20 is going to serve as the buffer for that. Location 21 just has a 255 in it. That's just all ones that I'm going to load into the accumulator. As I approach the halt statement, I want something to alert me that I'm going to reach that halt statement. So I'm going to load all ones in the accumulator, then I'm going to clear the accumulator, and then I'll have the halt statement. That's just to help me avoid sailing right on through the halt statement and starting the program over again and getting lost. It's pretty difficult as I move through these subroutines. But I wanted to do that just to kind of show how the stack operates with the subroutine. So I'm going to go over here to the front panel. I've already compiled this program and loaded the object code into memory, and I've set the program counter to 30. So we're ready to go ahead and start. So I'll just step through the program, and the first thing we'll do is load the accumulator, and we've loaded it with 5. The next step, we'll add 20 to the accumulator. That was that data in location in memory location 12, and it's been added to the accumulator. So now we've got 25 in the accumulator, and our next step then is to store that into into location F, which is our buffer. Next, then we call subroutine 1, and you can see the stack pointer is actually all 1s, and that's actually a decremented from all 0s to all 1s. I know it looks like it went the other way, but because it kind of rolls around. So now it's pointing to the top of memory, location 255. And before we go and look at that, we'll go a couple more steps. We have the load Y, and here's where I put the 1 in the Y register to tell me that I'm in subroutine 1. Next, we'll write the contents of that buffer to the output stream. That's what the 1 in the instruction register is telling us. And then let's go ahead and look at the stack and the output stream. So first, looking at the stack, if I go here at location 255, you can see we have this value, which down here I wrote or I put comments next to the subroutines to tell us what to expect on the stack. So we've got our value of 38, and that'll again load into the program counter when we leave this subroutine, and it'll direct us toward this next instruction. And we'll go ahead and look at the I/O panel, and you can see that we've written that 25 value to the output stream, and we've incremented the I/O marker. Now we'll go back to the front panel, and our next instruction should be to clear that Y register. And again, you can see now the Y register's been cleared, and now we'll return to the we'll get the return statement and return to the main body of the program. We've got zeros in the stack pointer, and there's our 38 in the program counter. So the next instruction we'll see is that go sub to go to subroutine number 2. Click on the right thing. There's our go sub. Stack pointer's been decremented, and we'll just kind of proceed through subroutine 2. Next thing is we've loaded the X register now. That says, okay, we're in subroutine 2. We'll load the accumulator with a value of 10. We'll go ahead and store that. And now we'll call subroutine number 1 to write that data to the output stream. And you can see the stack pointer is decremented once more. We'll go ahead and do one more step, and it'll load the Y register, so it tells us that we're in that subroutine 1. Now, if we go and look at the stack, we'll see we have 2 return addresses. We've got, what is this, 98? So this is, we're in subroutine 1, and when it returns from subroutine 1, it's going to go to 98 here in subroutine 2 and finish out there, and then that'll direct us back to the main body, which we'll actually call subroutine 3. So we'll go back to the front panel again, and we just loaded the Y register, so our next command should be an output, and we'll look at the output stream after we've run through the rest of the program. Now we've cleared the Y register, so we should see a return. This is next one is a return command, and we've incremented the stack pointer now, and we're going back to subroutine 2, which loads the X register with zeros as it prepares to return to the main program. Now we've got the return statement in our instruction register, and we're going back to the main program. In the program counter, you see we have 40, and that's what came off the stack and was loaded into the program counter, and that's directing us to this next instruction over here on the right in the assembly code. Next, then we'll go ahead and step, and now we've jumped into subroutine 3, so the stack pointer has been decremented once again. Next statement should load a 3 into the X register, and it does. Next we should load the accumulator, I think with that 20. Yeah, there we go. Loaded the accumulator with, is that 20? Yeah, it looks like 20 to me. And now we'll store that into our output buffer, and now we're going to call subroutine 1 again. So we've decremented the stack pointer, and well, let's step forward one more, and now the Y register has a 1 in it. So we've X register tells us that we were in 3, and Y register tells us we've called 1 from it. Again, this is just what I programmed into this this particular routine. It's not standard fair, shall we say. Um, so I've already loaded the Y register. Next thing is going to be our output statement. There's our output statement, so we're writing the contents of F to the output stream. Next, we cleared the Y register as we prepare to leave subroutine 1 and go back to subroutine 3. So we've done that, and you can see we've incremented the stack pointer. We'll step again. We've cleared out the X register as we're about to return to the main body of the program. There's our return statement. The stack pointer is now set to zeros, and we've loaded the program counter with 42. Over here on the right, you can see I've got it highlighted 42. So that's going to, the next thing we see will be to load the accumulator with all ones. Let's go ahead and step to that. There we go. We've loaded the accumulator with all ones. That's my heads up that a halt's coming. Now we've loaded it with all zeros. And the next statement is our halt statement. And if we go and look at the I/O panel, we can see that we've outputted 3 bytes of data, and the output marker has been moved. So that shows you how the stack is used for subroutines. I thank you for watching, and I hope you found it interesting.